when we actually go to graph the square root function, we're just going to go ahead and make a big table of values over here somewhere and put a bunch of x values in and get y values to pop out. But we got to be a little careful about how we do that. And we are going to start with the domain of the function, which means making sure we don't square root a negative number, which, like I said before, means looking underneath this square root symbol and making sure that this part, just this part, I don't care about this, just the part under the square root symbol has to be greater than or equal to 0. So I'm going to go ahead and write that out and solve that real quick. Make sure it's more than or equal to 0, solve for x, and that's going to be my starting point for my table. So I'm going to make a table. Let's see, let's do that over here. My x value will be 3. And now I got to find other good x values. But unlike times in the past where I would just kind of pick numbers willy-nilly, or the first number I found I might put it in the middle of the table, I'm not going to do that here. For one thing, this is the smallest number I'm going to use because all the other x's have to be greater than or equal to 3. But secondly, we're working with Alex, and even if we weren't, we want to get exact values, like points we know exactly where they are, which means we need to get numbers that we can square root. Numbers that if you say, hey, what times this makes 4, what times this makes 9. So we're going to look at perfect squares, but I can't just plug perfect squares in willy-nilly either. What I have to do is make sure that the square root ultimately ends up being a perfect square. So I need to figure out what makes this 1, what makes this 4, what makes this 9, what makes this 16. And that, whatever x values do those different things, those are the ones I'm going to use. So I can't just, some people can look at this and just kind of know that, okay, so you want x to be 4 then, or you want x to be 7, or you want x to be 12. And if you look at that and you know where I'm pulling those numbers from, that's great. Then you don't need to worry about what I'm about to do next. But if you're not sure where I'm getting that number from, if I want this to be equal to 1, I gotta say, when does x minus 3 equal 1? And I'll solve it. If I solve that, it's pretty clear that x has to, if I add 3 to both sides, that'll be an x value that I'll use 4. Then I'll say, what makes this have to be equal to 4? What makes x minus 3 equal 4? Because I can square root of 4. And if I solve that, pretty clearly I can see x is going to equal 7. And we'll just do one more for fun. What would make this underneath thing equal 9? What makes x minus 3 equal 9? And that would be 9 plus 3 is 12. That's probably too many points. The next part then is just to take each one of these different x values, plug them into the function, and see what the y value is so we can plot that point well. So now that I've rearranged the entire screen, and I've taken those different values and I've plugged them into the function itself, I get square root of 3 minus 3 or 4 minus 3. You can read these. You can see what they all become. The first one becomes the square root of 0 plus 2, which of course is just the square root of 0 is 0, plus 2 is 2. So I plot the point 3, comma 2. For this next one, I do the square root of 4 minus 3, so I'll do the inner calculation first. 4 minus 3 makes a 1, so I have the square root of 1 plus 2. Of course, the square root of 1 is equal to 1, plus 2 more is 3. So that'll be a 3. 7 minus 3 makes 4, so I'll have the square root of 4 plus 2. Square root of 4 is 2, and then 2 plus 2 is 4. That'll become a 4. And this last guy, 12 minus 3, would of course be 9. So I have the square root of 9 plus 2. Square root of 9 is 3 plus 2 is 5. So I'll have 5. So we'll go ahead and plot the point 3, 2, 4, 3, 7, 4, and maybe 12, 5 if they want me to do one more. And you might be noticing the pattern, hey, those just went up by 1. Do I have to do this every time? Yeah, these are going to go up by 1 every single time, but what these do is a little bit different or funky. It goes from 3 to 4 to 7 to 12. Now, I will be honest with you, for those of you who enjoy patterns, there's a pattern in here as well that kind of shows up if you can catch it. I don't want to tell you, but if you're looking for it, you might be able to find it. So good luck, and be patient with yourself.